Alright, so this video is for when they change the b value. So you'll notice here that I've started with the basic sine graph. And one of the things we need to talk about is period. So in this case, the period is where does the graph start again with the same pattern. So basically we have a period of 2 pi and then it starts again with the same pattern. So that is the standard period for sine of x and cosine of x. So let's look at an example here. Let's say I have g of x equals sine, and let's go ahead and go with x over 4. Okay. Basically what you need to do is if b changes, so I'm going to write this actually down here so I don't run into anything else I'm doing. So if b changes, basically step 1 is that you need to calculate period. The period. And the period has a formula, and it was in the investigation. It's also in your notes or in the textbook on page 262. So the period is going to be 2 pi over the absolute value of b. Now in this case, we have x over 4. Now b is supposed to be whatever's multiplied times x. So in this case, x over 4 is the same as x over 4 equals 1/4 x, right? So you need to be able to see that the 1/4 is the b. So to calculate the period for this problem, I'm going to do 2 pi divide by 1/4. And when I do that, I'm going to get 8 pi. Okay. So here's what that means. This graph started at 0 and ended at 2 pi for one period. Our new graph is going to still start at 0, but it's going to end at 8 pi. Now, in order for us to accurately fill in these x values, I basically need to split this into 4 sections. So look at your graph. If you notice, the graph has 1, 2, 3, 4 sections. So basically you want to take this 8 pi and divide by 4 to find out how far apart. Divide the period by 4, and it's always 4. It's not unique to this problem. Always divide by 4 to determine how far apart the x values are. Okay, so in this case I have 8 pi divided by 4, which is going to give me 2 pi. So what that means is that from 0 I'm going to add 2 pi. Okay, then I'm going to add 2 pi again. So 2 pi plus 2 pi gives me 4 pi. And then I'm going to add 2 pi again, so I'll get 6 pi. And then you add 2 pi again, and you should be at the end of your period. If you're not, maybe you've been adding something wrong, okay? So basically, when the value of b changes, the x values will change. Okay, sorry, the x values will change. And basically you are doing these calculations to figure out how to change the x values. Okay, now the first x value, 0, will still stay the same, but everything after that will be based on how wide or narrow your graph is. So when b changes, it only horizontally compresses or stretches your graph. It won't change the max and min. It won't change the y values at all. So all of these y values, you'll still put them into the table. So this is 0, this will be 0. This is 1, this will be 1. This is 0, this will be 0. This is -1, this is 0. Okay? So when I go to graph this, the period is much, much longer, so it's going to be way stretched out. So I still need to just sort of extend my graph. Here's 3 pi, here's 4 pi, 5 pi, 6 pi, 7 pi, all the way to 8 pi. Okay, so 0, 0 is a point. 2 pi and 1 is a point. 4 pi and 0 is a point. 6 pi and -1. And then 8 pi, back to the starting. So basically your graph has been horizontally very stretched. Okay? All right, so I think we should do one more example of this. This time I'm going to use, let's say, 3. Okay. So the first thing I need to do is calculate the period. So I'll come down here and I'll do that. So to calculate the period, I'm going to do 2 pi over the absolute value of 3. Oops. And I'm going to get 2 pi over 3. So basically the starting point is 0, but the ending pi, the ending part will be 2 pi over 3. Okay? Then I'm going to take 2 pi over 3 and I'm going to divide the whole thing by 4. And what you're going to get is 2 pi over 12, which is going to be pi over 6. And if you need to, you can definitely use a calculator to do these calculations. So for example, here you could have done 2 pi over 3 and then divide the whole thing by 4, and it'll tell you 1/6 pi. All right, so here's what that means. That means that when I go up here to do my x values, each time I'm going to be adding pi over 6. So 0 plus pi over 6, you can put it in the calculator, but you shouldn't need to, is going to be pi over 6. Okay, so pi over 6. Then for the next one, you're again going to add pi over 6. Okay, so you get pi over 3. Again, you're going to add pi over 6, so I can actually just hit enter again. It'll take the previous answer and add pi over 6, and I'm going to get pi over 2. Okay, so those are all the x values. Each time you're increasing by pi over 6. Now if I do plus pi over 6 again, just make sure that you get your period. Okay. From there, we already talked about all the y values stay the same. They haven't changed. Okay. And you might be wondering how to put that on this graph because maybe you're having trouble seeing, But basically 1/6 is going to be quite small. So what you have here is basically here would be pi over 6, here would be pi over 3, here's pi over 2. So I can add those in writing if you want. Pi over 3. And then after pi over 2, I almost immediately will still have this 2 pi over 3. Okay? So here's what happens. I have a point here, up, down, down, and back up. Okay, and obviously I could keep going, but basically what you need to notice is that because this is a value where the absolute value is greater than 1, it's going to be compressed. So it's going to oscillate back and forth between 1 and -1 much faster than the parent graph, or especially the one where we had x over 4. Okay, I'll make a separate video for cosine, but it's the same idea.